everybody. So in this video, we are going to discuss a very important algebraic identity as per an Olympiad point of view. That is, the biggest algebraic identity, in high schools. That is a cube plus b cube plus c cube minus 3abc identity, right? So what is this identity? Let us prove it directly and then we'll go to the result. So you have got this thing a cube plus b cube plus c cube minus 3abc, right? So basically, can we say over here that a cube plus b cube, can you write it like this? A plus b the whole cube minus 3ab into a plus b. You must have studied this identity as well. A plus b the whole cube minus 3ab into a plus b, and then you have got already c cube and minus 3abc over there. I hope that's clear. Now you see, if I take these two things in one group, that is a plus b the whole cube and c cube in one group, and if I can use a cube plus b cube identity, or I can say x cube plus y cube identity. What is x cube plus y cube? I can show it over here. X cube plus y cube is what, guys? It is x plus y multiplied by x square minus xy plus y square. That is the identity, right? So over here as well, if I can use x cube plus y cube identity, it will be x plus y, which is a plus b plus c. In the bracket, it will be x square minus xy, that is a plus b into c, plus y square, that is c square. Right? That is the first thing of this identity. Now you see over here, out of these two things, can I take minus 3ab as common? I can take minus 3ab as common. So I'll be left with a plus b plus c. You see, a plus b plus c in the bracket. I hope that's clear. Now you see, from this whole expression, can I not take a plus b plus c as common? A plus b plus c as common we can take over there. So you'll be left with a plus b plus c over there. And in the bracket, you will be left with this minus 3ab. So this you can just open it up. A plus b the whole square is what, guys? A square plus 2ab plus b square. Correct? And then if you see this part, it is minus AC minus BC, and then you have got C square, and then you have got minus 3AB over here. You see this, right? And then you can further simplify this thing. This is A plus B plus C, and then in the bracket you will get A square plus B square plus C square. So that is A square plus B square plus C square over there. And then you see 2ab minus 3ab will be minus ab. You are getting minus bc over here as well, and you are getting minus ac as well. You see, that is the identity. That a cube plus b cube plus c cube minus 3abc, it is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. I hope that is clear. That's hell of an important identity basically. I hope that is clear up till here. Now let's see a question on the basis of it. You see, you've got this question over here, that if a by b plus b by c plus c by a is equal to 6 and b by a plus c by b plus a by c is 2, you have to find the value of a cube plus b, a cube upon b cube plus b cube upon c cube plus c cube upon a cube. Now you see, that might look a bit easy. That is easy. But if you remember this identity, then you can do it easily. See this, guys. The only thing which you have to assume over here is, can I take x is equal to a by b? Can I take y is equal to b by c over here? And can I take z is equal to c by a over here? You see this. You see, a by b, b by c, c by a. Correct? Now basically this will be what, guys? Then this is x cube plus y cube plus z cube over there. x cube plus y cube plus z cube. And then what is this, guys? You see, if you multiply x and y, if you multiply a by b and b by c, what will you get? See this, a by b into b by c. What is this? This will be cancelled out. Isn't it a by c? You'll get a by c. Similarly, if you multiply these two, if you multiply b by c into c by a, what will you get? B by a. Isn't it b by a? If you multiply the first and the last, if you multiply xz, x and z, so a by b into c by a, isn't it c by b? So what does it mean? This is nothing but xy plus yz plus xz. It has been given to us, and that is equal to 2 over here. I hope it is clear. And this is nothing but, you know already, a plus b plus c, x plus y plus z, not a plus b plus c, x plus y plus z. So x plus y plus z is 6. This thing is given to us as 2. We have to find the value of this expression, nothing else. Now you know this identity, right? You see this, you know this identity, that x cube plus y cube plus z cube, right now we have seen in this class, minus 3xyz. What is that equal to? It is nothing but x plus y plus z into x square plus y square plus z square minus xy minus yz minus xz. Correct? We know this thing. Now you see over here, if you multiply these things, if you multiply x, y and z, what will you get? You see, that is a by b into b by c into c by a. What is that, guys? This is nothing but 1. You can check it. This is nothing but 1 only. So what does it mean, guys? You can just put the values, plug in the values over here. So x cube plus y cube plus z cube minus 3 you will get. That's correct. Now you see, x plus y plus z is already there. That is 6 as per this question. X plus y plus z is 6 over there. So this thing is 6. Now you see, we don't know this value. Now you might know this identity as well, that x square plus y square plus z square. If you have, can I write it like this? X plus y plus z the whole square, x plus y plus z the whole square minus 2xy 2yz minus 2xz. You know this thing, guys? It's a class 9 identity actually. Now you see, minus xy, yz, xz is already there. xy, yz, xz is already there as per this question. Now basically, this is nothing but 6 times of x plus y plus z is already there in the question. What is that? X plus y plus z is 6. So that is 6 square. And this is nothing but minus 3 times of xy, yz, xz. You see this. 3 times of xy, yz, xz, and that is equal to 2 only. So obviously you see, you know all of these values. 3 you can take on the other hand side. You can find the value of x cube plus y cube plus z cube. That's it. Obviously you can calculate it. Just take 3 on the other side and simplify. So I hope it is clear. You see, this is a not very tough, but yet a tricky question on the basis of, you know, this a cube plus b cube plus c cube minus 3abc identity. I hope it's clear, guys. Just check the values and then you can obviously simplify. Now you see, there is this special case on the basis of this identity, and that is the most important thing actually. The identity is very much important, but the special case is also is more important actually. See this. Right now we have seen the identity that if you take x cube plus y cube plus z cube minus 3xyz, right? Over here it was what, guys? X plus y plus z multiplied by x square plus y square plus z square minus xy minus yz minus xz. Correct. Now suppose if I take x plus y plus z to be 0. If I take x plus y plus z to be 0, what will happen? You see, 0 into anything will be 0. So what will I get, guys? Then x cube plus y cube plus z cube minus 3xyz. That is equal to 0 or not? Obviously. So from here, will you get x cube plus y cube plus z cube? X cube plus y cube plus z cube. That is equal to 3xyz. This is the most important thing in this identity. That if x plus y plus z is 0, if ever you see x plus y plus z is 0, you can just think that x cube plus y cube plus z cube will be equal to 3xyz. Just remember this thing for life. And that is the most important thing. Let's do a couple of questions on the basis of this specific result on the basis of this identity. Let's try doing this one, guys. That if it is given that a plus b plus c is 0, can you find the value of, I can write it properly for you, a plus b the whole square upon ab, b plus c the whole square upon bc, and then c plus a the whole square upon ac. You have to find the value of this thing if it is already given that a plus b plus c is 0 to you, right? Now you see what I can do in this case. That is the first thing, that in place of a plus b, can I write minus c? Yes, in place of a plus b, I can write minus c. So minus c square it is basically, and minus c square is c square only, right? Then in the same manner, what is b plus c? From this equation, b plus c is equal to minus a. b plus c is equal to minus a, and square of it will be a square only. So a square upon bc plus. You see, a plus c from this equation, can I say it is minus b? A plus c is minus b. Square of it will be b square only. So b square upon ac. Now you see, if you don't know these literals, if you don't know these variables, you will treat them as prime numbers only. That's how you find LCM. So basically finding LCM in this case is like finding LCM in this case, actually. Right? What is the LCM in this case, guys? It will be 2 into 3 into 5 if you apply the basic knowledge of LCM over here. So in the same manner over here, the LCM will be ABC only. Now how will you do that? ABC divided by AB. What is that? C. That C will be multiplied in the numerator. So you'll get C cube plus. In the same manner, ABC divided by BC is A. That will be multiplied in the numerator. So you'll get A cube. In the same manner, ABC divided by AC is B. That will be multiplied in the numerator. So you'll get B cube. Have you got that, guys? Now you see this in the question. It is given that if A plus B plus C is 0, it's given that. So can't we say that A cube plus B cube plus C cube will be 3ABC? Have we done it today itself? That if A plus B plus C is 0, then A cube plus B cube plus C cube is 3ABC. This will be cancelled out. So 3 is the answer. I hope that is clear, guys. In the same manner, let's do a more tricky question, although that is also direct on the basis of this identity only, if you are able to identify this, link. So for example, somebody will give you to solve this equation. Oh my God, I have to find cube of all these things. Obviously, you don't have to do anything over here. They are not telling you to find cubes because you won't be able to do that. It will take too much of time. Maybe you will be able to get the answer, but it's not just about getting the answer. It's about getting it on time as well. You have to you have to improve your efficiency and speed as well, right? So what we can do over here, you see this is nothing but x square plus x minus 2 the whole cube. And then plus, this is 2x square minus x minus 1 the whole cube. Now basically guys, if I take it on the other hand side, that is minus 27 into x square minus 1 the whole cube, that is 0. Is that clear? That is 0 only. Now basically if you see this expression, minus 27 is minus 3 cube. Is that clear? And then you have got x square minus 1 the whole cube. Then if you can write it like this, minus 3 into x square minus 1 the whole cube. Obviously you can do that guys. So this is basically minus 3x square plus 3 the whole cube. I hope it's clear, right? So what does it mean? The same expression over here can be changed like this. It is x square plus x minus 2 the whole cube. Then you have got 2x square minus x minus 1 the whole cube. And then this very expression can be written like this, right? So it can be written like this, minus 3 into x square plus 3 the whole cube. And that is equal to 0. You see this thing. Now you see over here, can't you observe that this plus this plus this is 0? Are you able to observe that? I mean, you can check it, x square plus x minus 2, and if you add this to it, 2x square minus x minus 1, and then you have got minus 3x square plus 3. What will you get over there guys? You see x square plus 2x square, and this is 0. Cancelled out, minus 3 plus 3. This sum is 0 or not? What does it mean? It means that if a cube plus b cube plus c cube, that is coming out, I mean, is equal to 0. I mean, you don't have to bother about that. If a plus b, if you consider this thing inside the cube root to be a, cube to be a, and this as b and this as c, aren't we getting over here a plus b plus c as 0? Tell me. So if a plus b plus c is 0, then a cube plus b cube plus c cube is what? That is 3abc. You understand that? So this whole expression will be suddenly simplified to 3abc. So 3 into x square plus x minus 2, and then this is 2x square minus x minus 1. And then this is minus 3x square minus 3x square plus 3. And that is equal to 0. If a plus b plus c is 0, then a cube plus b cube plus c cube is 3abc. Suddenly using that identity, you have simplified it. Now you see, that's a piece of cake now. You just have got some quadratics and then you have to just simplify that. Before actually simplifying, you can take minus 3 as common from this as well. Minus 3 as common. So minus 3 into 3 is minus 9. So this is basically minus 9. And you see this over here, you will be left with x square minus 1, right? You can factorize it. X square minus 1 will be, I can show you, it is x square minus 1 square. So a square minus b square identity you can use. That is a plus b into a minus b. And that is equal to 0. Correct? Now let's factorize these quadratics. If you know something called splitting the middle term, you can factorize it quickly. So maybe I'll explain, that is x square plus x minus 2. Wait, x square plus x minus 2. Maybe I explain over here itself. So x square plus x minus 2. So how do you factorize quadratic polynomials, guys? You see, coefficient of x square is 1, constant term is minus 2. So you multiply those things, right? And the middle coefficient is 1. So you want two numbers whose product is minus 2 and sum is 1. So that will be what, guys? 2 and minus 1 or not, tell me. That you will get from the factorization of this. Take the coefficient of x square and the constant term, multiply them, and take the middle coefficient. You want two numbers whose product is this and sum is this. That you'll get from the factorization of this. You can get more, higher factorization in this. This is a very basic one. So therefore over here, x square plus this can be written as 2x minus 2. So you have got two groups over here, first one and second one. From the first one you can take x as common, you will be left with x plus 2. From the second one you take minus 1 as common, you will be left with x plus 2. Once again you can take x plus 2 as common, you will be left with x minus 1. You can check for any calculation mistakes obviously. So this is x plus 2 and this is x minus 1. Check for any calculation mistake guys. Obviously I can do that as well, needless to say that. So now you see this part, this is 2x square minus x minus 1. I can do over here 2x square minus x minus 1. Again the same logic, coefficient of x square and constant term. The product is minus 2. So how can I split minus 1? You see minus 1 can be written as minus 2x plus 1x. Yes or no? Because then the product will be minus 2 and minus 1 is already there. Right? So you have got the first group and the second group. From the first group you take 2x as common, you will be left with x minus 1. From the second group take 1 as common, you will be left with x minus 1. Just check it guys. Let me just check it. Correct. So you can again take x minus 1 as common, you will be left with 2x plus 1. So you see this is nothing but x minus 1 and then this is 2x plus 1. So that is the, you see, complete factorization. You can check it. Now what are the roots of this equation? Put this is equal to 0, you'll get minus 2. Put this is equal to 0, you'll get 1. Put this is equal to 0, you'll get 1 only. Put this is equal to 0, you'll get 1 only. Put this is equal to 0, you'll get minus half. Put this is equal to 0, you'll get minus 1. So you see these are the solutions of this equation. You can check it. Obviously I can commit any error, but the main logic over here was what? You cannot use identities to open up these. You will not get the answer. You might get it, but it will take too much of time. So the simplest thing in this question is to convert it in this form, that if a plus b plus c is 0, then a cube plus b cube plus c cube is equal to 3abc. Check for any calculations. I hope that is clear guys. So you see that is a very important, I'll write very raised to the power infinity important, especially when you consider Olympiads up till high school level. I hope that is clear. Now you see there is yet another important result in this identity, which I want to show it over here itself. Suppose I multiply by half, multiply by 2 in the numerator as well as the denominator over here. See, by 2 in the denominator and by 2 over here I can multiply. You'll understand why I'm doing it. So this is 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ac. Right? I hope that is clear. Now you see over here, this is nothing but half into a plus b plus c multiplied by, you see, a square b square I can use and minus 2ab. Isn't it a minus b the whole square? Similarly, you see 1b square I have used over here. Over here I have used, but 1b square is left. So b square from this and c square from this and minus bc. Isn't it b minus c the whole square? Then in the same manner, c square from this and a square from this and minus 2ac. Isn't it c minus a the whole square? Tell me. So that is another important result, that a cube plus b cube plus c cube minus 3abc is equal to half into a plus b plus c into this thing. Basically, they make inequalities out of this, and that's very important. But we are not discussing, we are not going into that, because I mean, in this session, we are not talking about inequalities. I'll make a separate video on, inequalities. So don't bother on that, about that. So I hope that is clear, guys. That's a very important identity, and I hope you have learned much from this. Obviously, you need to practice many more questions because just by seeing a video, it's not absolutely enough. So that's all we needed to discuss over here, guys. Don't forget to like, share, and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And don't forget to subscribe to the Telegram channel as well, because whatever is being discussed in live sessions, not in this session, you'll get the PDF of those sessions in the next 1 hour or so. So that's all we needed to discuss, guys. We'll come up with a different video on many concepts on the basis of, Olympiads up till high school, like IOQM and all that. Bye-bye, guys. Take care, everybody.